Okay, so today we're up to section 2.3, and typically I'll try to get somebody to give me questions that they had trouble with while they did their homework, but that may or may not happen. And so I wanted to go over quickly to our homework. And I want you to see the calendar for a couple of reasons. This is today, October 11th. And so my plan is to do 2.3, and that'll be due Wednesday. And I think I'll probably get to a little bit of this 2.4 maybe. And so that's the plan. But I also, this changed because I saw the error. 2.3 is what we definitely need, and so on. But I want to call your attention, by Friday or by Wednesday, really, we've covered chapter 1 and 2. And notice on Monday, the following, October 18th, there's a test on it. And so what are you going to do? Well, first of all, you'll finish your homework. But then what I wanted you to see is kind of at the bottom of this. Let's keep going. So here's the chapters that we've been working on your homework. But going further down, there's a section called test reviews. And so I wanted to call your attention to test 1. And so literally there's a set of problems for chapter 1. And so I looked at this a minute ago, and things vary each time you do it. So for instance, if you did it once, but then you said, oh, gee, I need more practice. If you came back later, the problems would be slightly different. And so that's good. You get a fresh set of questions. And so this is just about perimeter. And if we have time on Wednesday, we'll definitely do some. But this is definitely, this would be useful to you. And then there's a chapter 2 review. And so again, this is different than the one I looked at a minute, an hour ago, whenever I looked. And so these are the kind of problems you could expect. And so this would be a smart thing to do. If you have the time, I would definitely do it. Any question about where that was? And so it was kind of like at the bottom. You keep scrolling down until you get beyond the homework. Okay. But the thing I wanted you to catch was this test. So what we'll do is to do a test, you'll need to turn on your video. And so it's almost like we're sitting in a classroom, and I'll give you, usually there's a password to take the test. And then you'll just take it while you're on Zoom, and we'll turn off our mics so we don't have to bother anybody. And then when you're done, if you finish early, you can leave. So that'll give everybody the full, what was it, little over an hour to take it. And it's typically somewhere between 15 and 20 questions. So it should work time-wise. And so there should be plenty of time. And so if anybody has individual questions about that, you can either ask now or later. But I definitely wanted you to make that. I'll probably tell you this again Wednesday because I don't want you to forget. Okay. How's that? Everybody good? Well, I don't know if we're good or not. So anybody have a question before I begin? Because I want to do 2.3. Okay. I'm not going to beg. So here we go. Whoops. Let's try this. So 2.3 starts out as about prime numbers. And what I've found is occasionally I run into a student that's never been taught it. Prime numbers are so important. This is a critical section in this book. prime numbers are sort of like the building blocks of all the other numbers. And so, for instance, instead of seeing, say, the number 15, 15 is not 15. 15 is actually 3 times 5. And this is what it took to build 15. And so instead of looking at the 15, we're taking into account the fact that it was really made up of 3 times 5. And that's going to give us clues about how to do all kinds of problems, especially fractions. So if you had trouble with fractions in the before, this is what probably stood in your way. And so we need to see things like this. Now the prime numbers, there's 2 definitions. One definition is when you multiply a prime number, the only way to do it is to multiply that number by 1, and that's it. So for instance, if I took the number 13, the only way to get it is 13 times 1. There's no other multiplication to do this using whole numbers. Is that okay? So 13 times 1, that's it. There's only one way. Now, there are numbers that are not prime, and an example would be 10. Now, 10, of course, is 10 times 1, but who cares? Because there's a second version of it, 2 times 5. So this is not prime, not, N-O-T, not. And they call it composite. It's composed of other factors. And so that's the word composite. But we're interested in these prime numbers. These are special. Give them this, special. So since every number multiplies by 1, 1 is not a prime, but the first prime number is 2. And if you think about it, okay, even though it's even, the only way to get it is 2 times 1. Now, the other way to define a prime number is with division. And so if you had the number 2, by division, the only number that would divide it would be a 2 or a 1. In other words, the only thing that can divide into 2 would be 2 or 1. I kind of favor this definition, but it really doesn't matter. It's the same thing altogether. So 2 is a prime number, and it's the only even number that is, because every other even number will be fitting into this category where it's going to be 2 times something. And so 2 is a prime number, 3. And so when you're trying to think of, is this a prime number or not, 3 is 3 times 1, period. That's it. And so 3 is good. And so I've got to skip the even numbers from here on. So 5 is good because 5 times 1, that's it. Okay. Next one, so you go to the next odd number, and the next odd number is 7. And 7 times 1, that's it. No other way. Now, when I get to 9, 9 fits this category over here. Although 9 times 1 is 9, it's also 3 by 3. So 9 is out. And so it's not prime, but the next one is 11. And so this is how you would build them. And you really need to kind of know these up to at least 20. So let's keep going. So 11 is prime because 11 times 1 is 11. That's all. 13 is good. This is a strange group of numbers if you think about it. But they're critical. And so 13 times 1, 15 is no good. 15 is 5 by 3. It's not prime, but 17, aha. 17 is good. 17 times 1, no other way to do it. It's not on any other list. And now I'm going to do 19. And 19 is on my list. And so this is a set of numbers, and I'm using this notation for a set. Is this the last prime number? No, there are huge numbers that are prime. And so 21 would be next, but it's no good. 23 would be prime. And I'm going to do this. But you could go further and further by looking at these numbers. And if you know your multiplication facts, and it's not just to know them, it's like it helps you, because then you'd say, did I see 23 on my multiplication list? And the answer is not really. And so 23 is 23 times 1, that's prime. So these are the building blocks. And so one of the things they're going to ask you to do is, can you take a number that's not obvious, or maybe it is, and create the prime factors? Now, factors are the numbers that multiply together to make a number. So 15 is 3 times 5. 3 and 5 are the factors, and 3 and 5 were both prime numbers. So let's take a bigger number like 20. Now, 20 is not prime. It's automatically excluded because it's even. So the only even prime number is 2. This is no good. The book shows 2 ways to get the prime factors. And so one way is if you know any way to multiply to get 20, anything other than 20 by 1, which doesn't do you any good. So what they suggest, maybe this might be something that would come to your mind. 20 is really 4 by 5. Now, 5 is a prime number, but 4 isn't. So you continue to break this down until you're down to the last bit. And 4 is actually 2 times 2, and the 5 carries. So what we have is 2 times 2 times 5. These are the prime factors. Now, if you think you somehow made a mistake from here to here, there's no problem. Just multiply it out and see if it's any good. 2 times 2 is 4, times 5 is 20, good to go. Now it helps to have these numbers in order. And so you can see them easy, where you put the 2s first and the 3s if you have them, and the 5s and so on, put them in order. It's easier to look at them and compare when they're in order. Now the other way, so that's the answer, 2 times 2 times 5. And the thing about exponents, occasionally you might see 2 times 2 is 2 to the 2nd power, right? Multiplied by 5. But this is just as good. It might be even better, but this is also correct. So there's another way to do it, and I'm going to take my 20. And this is using not long division, but short division. So this is, I'm going to make a list of my prime numbers, my, the first bunch. There we are. So there's a bunch of primes. The way to do it, prime factors using this division method, is you just start at the bottom and you work your way out. So you don't have to think. So 2, does 2 go into 20? Yes, it does, because the last number is 0, it's even. So 2 into 20 is 10. Now, if this was prime, we would quit, but it's not. So your question is, does 2 go into 10? And the answer is yes, it does. So 2 into 10 goes 5. Now, the minute you hit a prime number, you're done, because you can't break it down any further. So here's where the answer lies. 2 times 2 times 5. Okay. I find this a little bit easier, but the short division doesn't bother me. This forces you to put them in order, because you don't go with the biggest number you can think of. You start with 2. And you just work your way out. Let me try a different number. Let's go higher. Now, you might see that 3 goes into this or something, but you could start with 2. And then you'll have your answers, your factors in order. Remember the 2 goes into 36, 18. And so you can do this like this. 2 goes into 3 once, 1 left over. I'm seeing this as 16. 2 into 16 is 8. Okay, now what? If 2 goes again, you use 2 until it runs out, and 2 goes again, 2 into 18, it gets easier as you go down because the numbers get smaller. 2 into 18 is 9. Now 2's out of luck, so now I'm going to go to 3. 3 into 9, 3. And the minute I hit a prime, I've got it. It's 2 times 2 times 3 times 3. That's what 36 looks like. And I make up stuff, and you know that, so you might as well accept it. I call this a skeleton view of the number, sort of Halloweenish. Skeleton view, because you can see there's a pair of 2s and there's a pair of 3s, and that's more useful than seeing the number 36. Okay? And we'll show you different ways that this is used. Any question about this? So could we have done this the other way? If you learned it the other way and you were totally happy with it, does anybody know any factors of 36? So you have to know, you have to get started with this tree method. What times what is 36? Well, you might know that 9 times 4 is 36. Okay. And then 9 would have to be broken into 3 by 3, and 4 would have to be broken into 2 by 2. And then at this point in time, they're expecting you to arrange things. It's like playing with cards where you put your cards in order. That's what this is about. There was a chat. Does anybody have any? I guess that's just an old chat. So both methods give you the exact same answer, or something went wrong. So I recommend doing the way that seemed the easiest for you. See 57? So what if somebody said, give me the prime factors of 57, or tell me if it's a prime number? And it looks pretty unusual to me. And my first gut instinct is to say, oh, that must be prime. Nothing, would work for 57. But I want you to remind you of things. We have good little rules for 2 and 3 and 5. For 2, the number's even. For 3, if 3 is going to divide something, the digits add to a multiple of 3. So 5 and 7 is 12. 3 goes into this perfectly. And so it's one of those numbers where you might not have guessed it. And so I just want you to always be aware it's really easy to test for divisibility by 3. 2 does not go this because this is odd, but 3 does. And so if you can't do it short division, do it like this. 3 goes into 5 once. This 1 times 3 is 3. When you subtract, it's 2, and you bring down the 7. 3 into 27 is 9.
Does 3 work for really large numbers too?
Absolutely. If the number is divisible by 3. So if you add them and you get 3, 6, 9, 12, 15, 18, any number that divides nicely by 3, the whole number will divide by 3. So this one added to 12. It's just a trick, but it's a good trick because it's easy. So 57, according to this, is 3 times 19. Now remember, 3 is prime, 19 was also on our list. Remember 19, nobody divides 19. Is that okay? So there's no further way to go. But see, this is one of the ones that hide. And if you took a course, you know what they did? They only made the problem so difficult, and then I put a ceiling on it and said, we're not going here. But with prime numbers, you can go there, because that's the way in, okay? So does anybody need practice with this? So I could find a number. Let me see if I can find something. Yeah, the book has this one. So does anybody have an opinion about which way I should do these problems? I'm tempted to do the division. This is even, so I'm going to divide by 2. 2 go, and see, starting at the bottom doesn't hurt, because then you get it, you whittle it down until there's, you're down to a prime. So 2 into 60 is 30. It's still even. Use 2 again. 2 into 30 is 15. We're done with 2s. Now you know how 15 is. I'm going to go 3 next, and 3 into 15 is 5. That's a prime number. Here's my answer: 2, 2, 3, and 5. Now, let's say you had this terrible feeling that you've made a mistake. Do you ever have that feeling? I like to say it's somebody haunting you, somebody from your past saying, don't do that. I'll haunt you as well, to be honest. And so 2 years down the road, I'm going to be haunting you saying, don't do that. I don't want you to do that. So how do you quickly see that this is 60? Remember where you could move the commutative and the associative property? Remember how you could move things around in addition and in multiplication? Sometimes my laziness comes out, and what I see is this. Do you see this? 2 times 5 is 10. 2 times 3 is 6. 10 times 6 is 60. Guess what? I'm totally satisfied with that answer. Do you see what I did? I used those rules to make my life simpler. Now, starting at the bottom and working left to right, 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is, what is it? It is 60, but wasn't this easier? Do you see what I'm saying? I'm allowed, because of those 2 properties, the commutative, grouping things, and the associative, I'm allowed. And I can do it in a split second and get it right. And so I just wanted you to be aware of that. So that's the answer. 2 times 2 times 3 times 5, it's 60. We are good. Now, any question? Don't hesitate to interrupt, because I get tired of listening to myself. So one use of prime numbers, and I'm just going to use this one, is when you have a fraction and you're asked to reduce it. In other words, to simplify it, get it to lowest terms. In other words, this is not as simple as it could be. There's a simpler version of this, an equivalent version. And so we're trying to reduce it. Now, people had all kinds of ways to do this. And so if you learn to cancel, I'm not saying you shouldn't do it. Canceling is fine if you do it correctly. And so does anybody have a way they would do this? Or was this the kind of thing that you always got wrong? Or you likely got wrong?
Yeah.
You did get it wrong. Yeah.
I do 4 times 5 for 20 and 4 times 6 for.
This is definitely adapting what we just did. In other words, when you're seeing, although 4 is not a prime number, this is where it's at. It's the factors that allow you can reduce factors in a fraction. And so I have a 4 divided by a 4. Guess what? they can hit the dust and we'd be done with them. And the reduced version is 5/6. Now that can't be reduced any further, so we're pretty happy with that answer. Okay. Let me see if I can find a different one. 32 divided by 12. Now notice this is an improper fraction. Well, according to the book, the word improper, I like it actually. This is higher than that number, but we still are going to be asked to reduce it. And so, you know, one way is to do factors. Another way is, can you see something that divides both of them? That's pretty much the canceling method. And so can anybody suggest something that I could divide both of them by? Because we did use this before.
2.
Divide by 2, okay? So 32 divided by 2 would be 16. And 12 divided by 2 would be 6. The question is, are we done? And the fact that both of them are even tells us that they both can divide by 2 again. So let's just deal with it. Okay. So 16 divided by 2 is 8. 6 divided by 2 is 3. Now in algebra, 8 divided by 3 would be the perfect answer, the answer in the back of the book. But there is a tendency in this book to say, oh, would you kindly make that a mixed number? They're equivalent, so they're asking for the mixed number version. So this is 8 divided by 3. You know what that is. 8 divided by 3 is 2. How many left over?
2.
So it's 2 and 2
Thirds.
thirds. Chances are you have to read what do they want, give them what they want, but chances are they will go this way. So 2 and 2/3. Okay. Now, what number is going to divide?
2.
2. So if you want to go that method, and you don't have to write it, but you definitely have to do it. 8 divided by 2 would be 3. 56 divided by 2. It's a 2, 1 left over. 2 into 16 is 8. This is 28. Now, I want you to tell me if you think this is reduced.
No. No, it's 3 divided by 3.
Yes, maybe. Anybody? It looks tempting, doesn't it? Like it might divide more. But what is 28? 28. 2 into 28 is 14, right? 2 into 14 is 7. 28, this is the way it looks. 2 times 2 is 4, 4 times 7. But this is a 3. See, this
There's
is
just no 3 in
see
that
what I'm
equation.
saying? Yeah, see what I'm saying about the skeleton view? And there's no math book that ever said that, so I make up stuff. So keep that in mind when you try to tell somebody it's a skeleton view, because nobody will ever have heard it. But isn't that what it amounts to? You can see. You can't see it here maybe, but you can see it here. There's no doubt this does not fly, does it? And so what does that mean? That was good. Okay? And so it was very tempting. I guarantee you it was very, very tempting. But that's not There was another question. I'm gonna do this one. 1/2, 2/4. Oh, that's a funny one. Oh, this is putting numbers on the number line. I just found a funny question. Put these numbers on the number line. Where is 1/2? I already, what?
The middle,
Right in the middle. Where is 2/4? 2 divided by 4.
fourths in the middle.
It's the same place. Right?
Yes,
Even if you broke it up into 4 pieces, you don't have to. But 2 divided, and 4 divided by 8 would be also in that exact same spot. Is that okay?
mhm.
That was a silly problem. Okay.
Made me think though.
I thought it was silly. The minute I wrote it down, I said, that's silly. Okay. Any question about this? So when the problems start to get harder, this is where prime numbers are going to come to the rescue. And so that's what I'm interested in. Okay. Now, once we get past that, what we have to do, and I'm going to take a look at 2.4 and then we may do some review. 2.4, we're going to have to learn to add and subtract and multiply and divide fractions. And I know from past experience that many times people had trouble with these. Okey doke?
Yep.
2 of them are fairly easy and 2 of them require more effort. And on 2.4, they start with multiplication. And so I'm going to just say 1/3 times 4/5. Okay. So I've got a fraction here and I've got a fraction here, and I'm supposed to multiply them either with the dot or maybe with parentheses or whatever. What you're supposed to do is multiply across so that the 1 times 4 is here and the 3 times 5 is here. Now, do you have to write that? No, but that's what you're doing. In other words, you're multiplying across. Okay, so multiplication doesn't require too much work because you just multiply across, assuming you have a nice fraction. And I'm going to call these simple fractions. They're not mixed numbers. They're just a plain old fraction. And so 1 times 4 is 4. 3 times 5 is 15. Does this reduce? Because every single time, well, maybe not every single time, almost every time, they're going to expect you to reduce your final answer. It will say so in the instructions, but you better read them carefully. But you can just assume they want the simplest answer. They don't want 100 divided by 200. They want 1/2. Right? Don't give messy answers when you can give nice and clean, simple answers. And so this is a nice, simple answer. Now, occasionally, something happens. And so let me go. Okay. Now, I can multiply these straight across. 1 times 3 is 3. 6 times 10 is 60. But then I have the job of simplifying the problem. It is much easier to do it now when the numbers are small, before then you make them bigger and bigger and then have to bring them back down again. And so here's what it looks like. This is 1 times 3. This is 6 times 10. So that's, I put it in a single fraction to make it clear what we're going to do. this 3 in the numerator, the top, and this 6 in the denominator, the bottom, can be reduced. And if you've learned the canceling method, I have no problem with that, especially with small numbers. It's when you start to make mistakes, we better go to prime numbers. But I think 3/6 is pretty easy to do. Does anybody disagree?
Fine.
3/6. 3 goes into 3
Once,
once, 3 goes into 6
twice,
twice. Now I look at the problem. 1 times 1 is 1, and 2 times 10 is 20. Is that done? Done.
yes,
Done. We can't do any more with that. And let me keep upping the ante. I could write this as a single fraction, but you know what's going to happen. This fraction line is going to extend, which means I could reduce any fraction like the 5 and the 8 if they would, they won't. Or the 5 with the 10, anything from the numerator with anything in the denominator. Is that okay with you? It isn't necessary to make this step, but I want you to realize that the 5 and the 10 are fair game because this is in the numerator and this is in the denominator. Now what? The 5 and the 10, can that reduce? So ignore the rest, 5 and 10. 5 goes into 5 once,
Once.
5 goes into 10
twice,
twice. That was an improvement. But I set this up with another possibility here. This numerator and this denominator, 8 and 24, both divide by 8. So 8 goes into 8
once,
once, 8 goes into 24
3,
3 times. So if you've learned it this way, then you've got this, and you look to see it, will anything else reduce? And then what you have is 3 divided by 2. And because of this mixed number, like for the book, 3 divided by 2 is 1 1/2. Right? 2 into 3 is 1, 1 left over, 1/2. Now, the minute this gets ugly, and I understand ugly can come out. So let's see, 4 fifths, 35, 20. The minute this starts to get ugly, this is where, or you start to make mistakes because the numbers, and I can make the numbers bigger and bigger and bigger. But what I want to do is at a certain point, you might say, I would be so much happier to either go into factors or prime. This 5, I'm going to put down. This 35 is 5 times 7. I'm going to knock out the 5s, to be honest. This 4 and this 20, maybe you can see, you can do it with factors or you can do it with prime factors. This is 4 times 5. So what I've done is broken this down so I can see. The first thing I did was see that 5 and that 5, that was my first one. But the truth is, this 5 and this 5 are also fair game. It doesn't matter which one I do, I just can't do it twice. So 5 goes into 5 once and into 5 once again. Anything else cancel? How about the 4s?
The 4s.
Yeah. So 4 goes into 4 once, 4 goes this once. So at this point in time, I look to see, do I have anything left? I have a 1 and a 1, who cares, and a 7. and a 1 and a 1 and a 5. I don't think I can do more. This is now reduced. And so because of this improper fraction business, 5 into 7 is 1. We have 2 left over, 2/5. Okay. Now, so far, so good, until they do this. So this is the next version. What we had so far was a simple fraction multiplied by a simple fraction. And guess what? This doesn't really qualify, but we can make it. In fact, the way I wrote it probably is hinting at what I want to do. I want this 32. I want to start with a simple fraction times a simple fraction. Then it's very, very clear what's on top, what's on bottom, what's on top, what's on bottom, so that I don't get twisted up. And I set this up so that the 8 would go into 32. How many times, does anybody know? So this is your
4.
4, thank you. I mean, these are your multiplication facts. It just makes life simpler. 8 goes into 8 once, 8 goes into 32 4 times. So 7 times 4 is 28, and 1 times 1 is 1. Do you want to turn this answer in?
28.
Yeah. Remember what I said, even though they don't say it blatantly, in capital letters, give the simplest answer, unless they want a fancy answer. And I don't think they ever want 28 over 1. They want 28. Is that okay with you? Why make a mess when you can have it nice and clean? That's pretty much what we have. Does the fact that I use parentheses make a bit of difference?
You multiply.
It's still multiply, isn't it?
Yes.
Do I have to rewrite it? Not really. And so this is why I use a horizontal fraction line, even though, you know how, 7/8, sometimes you see it like that. But this is harder to see what's on top and what's on bottom. This way, I think it's easier. But what cancels? Anything? Shall we cancel up anything?
3.
How about the 3s? Hit the dust 3s. This is 3 into 3 once, 3 into 3 once. And so knowing that we're going to multiply across, 2 times 1 is 2, 1 times 5 is 5. That's good, isn't it? Okay. Now, well, let's see about this. Well, it's fractions, all right. But it doesn't look like the right form, does it? Remember when a minute ago, let's see if I can, here we go. A minute ago, back, I took 7 divided by 5 and turned it into 1 2/5. For this next problem that I'm going to do the reverse. And reverse, this is handier. This is called handy dandy. This is called not so great. So the way to get from here to here is this way. 1 times 5 is 5, plus 2 is 7 over 5. So what I have to do is I put it in this simple fraction form. The book calls it improper, who cares? It's a nice fraction. And so that's what I'm gonna do. 4 times 2 is 8, plus 3 is 11/4. Much better for what we're gonna do. This one, 5 times 3 is 15, plus 1 is 16/5. Once I start in the right form, it's gonna work. I could do this in the most ugly way you could imagine. I'm not. I won't do it. I refuse. I'm gonna do it this way because this is the best way. And so are you ready? You look and see the 11 and the 5, I don't think so. But how about the 4 and the 16? So you couldn't see it up here. But the 4 and the 16 are begging us to do something. Ready? 4 into 4?
Once,
Once. 4 into 16?
4.
4 times. And really, we're done now. There's no more. So you multiply across. I can do that. 11 times 4, 44. 1 times 5 is 5. And if they say they want a mixed number, well, you have to do it and write it out if you need to. I don't care. 5 into 44 is 8. 8 times 5 is 40. When you subtract, you have a remainder of 4. So this is 8 and 4/5. And I believe they want this one, but honestly, once in a while I experiment to see, I put in this answer to see if they'll take it and mark it wrong, or mark it right, rather. I prefer marking it right. But if they say mixed number or whole number, then that's what you need to do. I don't think that's too bad. So what's the deal? The deal is, if the original problem is not simple fraction times simple fraction, you make it a simple fraction. In this case, we had to take our 32 and divide by 1 so that we had it. In this particular case, we had 2 mixed numbers. That's okay. We know how to go back and forth to make life simpler for ourselves. And so we did that 11/4. We did that 16/5. And then we basically, then you just ignore the fact that the problem was kind of icky to begin with. Just ignore it and focus right in on this. And it's that 4 and 16 that we went after.
So you always
ahead.
divided across from each other and the numerator with the denominator.
I'm going to make an example of something that's a different story. The rule is that what's fair game in a multiplication of fractions is 1 numerator, top number, and 1 denominator. Do you see? In other words, I've only showed you ones where they were kind of like diagonal, but do you see anything that would fit that description?
15, 70.
Well, I don't think 5 and 7 want to cancel, but I see something different. These two are fair game. A numerator and a denominator. Even though they're part of the same fraction. I thought that's what you were asking. So
Yeah.
5 goes into 5 once, 5 into 10 twice. And there's nothing more. The 2 and the 3 don't do it. And so once you're out of luck, 1 times 3 is 3, 2 times 7 is 14. Now, this is my question. I haven't found a really good example to emphasize this. But if you did your work correctly here, is it possible that your answer will still need to be reduced? You want to vote?
No,
You don't want, your answer is no, or you don't want to vote?
no, I don't think you can divide it. I
No.
mean, by 3, you cannot divide 14.
Yeah, I think you're looking at the 3 and the 14. But what I'm saying is, if you check this out properly and there's nothing left, and then you multiply across, it's impossible for this to reduce further. So you do your job over here where the numbers were small.
Oh,
Instead, if you hadn't canceled it, it would have been 15 over 70. If you had just multiplied across, and then you would have had to work this down. Well, guess what? The more steps you have to do, the more you're likely to make a mistake.
yeah,
Believe me, I know that's a fact. So you want to tackle it here where it's easy than to tackle this. Okay, because this one wouldn't be good enough. You'd have to keep dividing, and it's possible you'd make a mistake, and so on. Okay, so how about this one? 3 times 4 5/8. So this is sort of a combination of 2 things we've done. So this is not in good starting form. What do I need to do? Anybody have a suggestion?
do,
Make the 3 into a fraction.
Okay, so what is it?
3 over 1.
Okay.
Hmm.
Okay, so that's the correction for this one. What about over here?
3 times 4 plus 5,
How much is that?
37,
Correct. 37 over
8.
Well, 37 doesn't cancel with this. 37 doesn't cancel with that. 3 and 8 don't work. What are we stuck doing? I couldn't cancel. I wanted to, believe me, but I couldn't.
Just multiply across then.
Multiply across, zip like that,
Mm.
and zip like that. So 37 times 3. This is 21, carry your 2. This is 9 and 2 is 11. Oh, what an interesting 1, 1, 1. 1 times 8 is 8. Before I leave this number, you see this 111? If somebody said, you had to break that into prime numbers or something like that, this is what it's made up of, 3 times 37, because 37 is also prime. Okay? But what was the clue that allowed you to know that 3 divides it? 1 plus 1 plus 1 is 3. Therefore, 3 divides it, guaranteed.
Mm.
But here it is. See, I'm doing this backwards. So I'm trying to emphasize this, but 3 times 37 is the prime factorization of this number, which is the biggest one we've had. Now, if you had to make that a mixed number, it's like, oh, darn, you have to do a little division. 8 divided into that. So I'm going to just do it this way, and then I'll put my answer here. 8 into 11 is 1. 1 times 8 is 8. When I subtract, 11 take away 8 is 3. Bring down the 1. 8 times 4 is 32, but I've only got 31, so it's got to be 3. 3 times 8 is 24. And when I subtract, this is 7. So it's 13, remainder 7 over
8.
8. Kind of lousy, but there it is.
Mm.
Okay. And so that's where I'm at. The book showed one more thing. Remember how, I think it was the very first class, we talked about words, sum, difference, product, and quotient. I'm sure that was in the beginning chapter. Sum is asking for addition. This is asking for subtraction, multiplication, and division. Right? And there's some other words too, but these are words that force you to do something. Here's another word. Of. Simple little word. The word of means multiply if there's a number here and a number here. This means multiply. In other words, the word of is in place of the word multiply. So here's an example, just so that you know. If I wanted 1/2 of 20, a number here, a number here, the word of in between, it's 1/2 times 20. And this, of course, doing it the way we've just been doing it, it would have been 20 over 1. Okay? Multiply. Okay? Now, just because you see a sentence that has the word of, that doesn't mean it's multiply. You've got to have a number here and a number on each side. And then it does mean multiply, and you can count on it. And so then this would be 2, and this would be 10. This would be actually, it would boil down to 1/2 of 20 is 10. Okay. All right. Any question? There was one more little topic in this, and I can probably do it next time. I'm not going to tell you the formula. Let's see if you remember the rectangle. Area. Anybody recall it?
Width times L.
Is this it? Length?
Yeah.
This would be the length, and this would be the width. Okay, that is the formula for area. And you think of area rug, you're trying to cover the floor. So area rug is in the middle there, how much area is covered. I'm going to draw you a triangle. And I want you to see this picture and this picture. If you were guessing how this compares to that, what's your guess? It's a visual thing.
1/2.
Exactly. And so every time you deal with triangles, you're dealing with 1/2. Now there's a little notation. I want you to see this little box. This is basically saying that this and this are perpendicular 90 degrees. You understand that? You want your walls in your house to be perpendicular to the floor. It would be nice, right? Do you want your walls nice and?
Yes.
My house in Maine was built in 1820. A lot of houses in the East are like that. I mean, especially where I was. You want the walls really good. Did they hold up for, a couple hundred years? Was somebody paying attention? Can you see that the half there? Here's another one. I want you to visually, I'm into visual. Do you see the rectangle? But the triangle is what fractional part of it?
Half.
It's a half. And so when you see triangles, I want you to think 1/2. And then we'll be able to do these problems. Instead of length and width, they're going to use this measurement, which they call the base, and this measurement, which they call the height. But there's going to be a 1/2 in there because they're really a half of what a rectangle might have been. See it visually?
Pues
So
half
I'll do that some more next time. But there's your formula. That's the last, let me just show you the out of here. This is their triangle. This is the base, which is the bottom. This is the height, which is perpendicular. See the little box? And the formula is 1/2 times the base times the height. And so you may have seen that before. We'll do more next time. So is that a plan? So I've talked about 2.3 and I've talked almost all of 2.4. So with the test coming up in a week, the more you can do before Wednesday, the better. And then we'll just do one more section and we'll have some time for review. Is that okay?
Yes.
Any question about how we'll do the quiz? So we'll just all come in. Everybody will do it. When they're done, they'll leave the class. And that'll work.
Oh,
Okay,
yes. I have a question.
good.
I noticed that I was trying to go back to my homework, but it's empty. Doesn't have
Oh,
it.
that happened to somebody else, but then when they went back, I think, didn't that happen to somebody else?
Because I was trying to print it.
It happened to me, but I don't know. I think I was just looking at it in the wrong format or something. I'm not exactly sure what I did, but it was right before
I thought,
class.
but then you've done it. You had credit for it, right?
Yeah, like I had done all this work, and then when I went to go talk to you about it and look it up, all of my work wasn't there, but that when I went back again, it was all there again. So I'm not exactly sure
Oh, okay.
what I had done. You might just like